In this video, we're going to cover the basics of the weld environment for Autodesk Inventor. To get into the environment for welds, just like most environments within Inventor, go ahead and click the Environments ribbon, and then we're going to click Convert to Weldment. And once we do that, we're going to get a dialog pops up that says, hey, this is going to get turned to a weldment, and you will not be able to go back to an assembly, a regular assembly file. And from what we found, there is only one downside to that, and that is the fact that you can't have positional representations, or pos reps as we call them. So if you need to have positional representations at this level or a level above, anywhere up the structure of the ware used, the weld environment is not for you. But typically it's not much of an issue for us. So we're going to go ahead and hit yes. And then you're prompted with the second dialog box. And in that second dialog box, you can pick the standard, and you can also pick your material. We went in and created custom materials for the basic materials that we typically use. And I'm going to go ahead and pick 1045. And then the BOM structure is automatically also set to inseparable, which essentially that's meaning that nothing in here is serviceable. Once it's welded together and you can't take it back apart. We normally just switch things to normal. But there are several other options, which what this is doing is dictating what parts are going to show up in your bill of material. So with purchase, because a purchase part typically doesn't have a bill of material, the bill of material will be ignored. And if you set something reference, it's going to be just that. It will not show up in any bills of material going forward. So as I mentioned, you cannot have positional representations in a weld environment. And to show that a little bit, here we have an up-level assembly. We have this weldment, which then goes up into this flexible weldment. At least that's what we named it. So if we look down here at this pos rep, we see that we have a flexible and a master. So you can see that that part's still flexible. And if we go the next level up, even though that is a weldment, we can see that that's still flexible. And we have two positional representations. But where the caveat is with the weld environment is they will not let you have a pos rep. So if we try to go into the weld environment, notice how it went grayed out. And that is because there is pos reps here. So if I just go in and get rid of this positional representation and hit delete, now I can pick the convert to weld environment, so I can convert it to a weldment. So if you ever run into an instance where you can't get into the weld environment, check to see if you have any positional representations. Also, if a component is converted to a weldment, welds are placed, someone goes ahead and does everything appropriately for the weld environment. If someone comes in later and creates a positional representation, the welds will stick, but it will not let you get back into the weld environment. So if you tried to edit something in the weld environment, be it a symbol or the actual weld bead, weld feature, you won't be able to get into that environment. And also notice that once you do convert something to a weldment, that it goes in and generates a weld ribbon. So you no longer have to go into environments and then go into the weld environment. The weld ribbon will be there and act just like any other ribbon. So as long as once it's created to a weldment, that ribbon will always show up. And then one last item is, as you noticed, you can have weldments flexible. So in this case, this kind of acts as a hinge or basically kind of like a bearing or bushing. So we can leave this unconstrained, and it can be flexible, because in reality we go the next level up, we want this machine to be able to be flexible. So we can go in and move it at this level, constrain it at this level if we want to be able to show different orientations of this. Since we can't have positional representations with a weldment, you can still leave it unconstrained and have it be flexible to get the intent that you want going forward. Now within the Inventor environment, there is out-of-the-box weldment templates, and essentially it's just an IAM that's already converted to a weldment. And what you can do with those is preset the material, and you can preset the bill of material occurrence, because essentially it's already converted to a weldment is the way to think of it. We personally do not use weld templates for the mere fact that we're typically designing from the top down or the middle out. And when you do that, you never know where your weld environment's going to happen or where your weldments are going to be. You know, that's kind of always an afterthought, or you create your structure afterwards once the design's pretty mature. So for that reason, we don't use weld templates. And then every part's treated the same. You know, we convert to a weldment, you get prompted with the 2 dialog box. It's just a consistent workflow. You don't have to have any foresight, okay, I need to have this be an assembly. So they are there. If you have the same type of thing you're doing over and over and over, templates may fit into your environment, but with the way we work, and we're constantly having new designs, new machine types, drastically different designs, we never know where that level is going to be. So we choose to create the weldment at the time that it's needed. So once you're in the weld environment, there are several other tools and processes involved. One of the first things you can do is do some weld calculations. And these calculators essentially will help you determine how much strength a weld has, or are you putting in a heavy enough weld. These calculators in themselves is a class within themselves, a separate session within itself, so we're just going to touch on it briefly. But you can basically put on the actual load, you can put on, you know, what your weld leg length or height is, you can put in your weld length, you can determine the different types of loading sets. So it's fairly straightforward. One other note is types of weld. So let's go with this guy here, and the type of weld bead. In this case, it's showing just one weld bead along the edge. Where we would normally weld this would be like that. So essentially we're welding the 3 sides of the part. So we'd be welding there, there, and there. So you can put in your requirements, your factor of safety, you can determine your material, and once you go ahead and hit calculate, it's going to generate some numbers. And what you need to do is look for anything that pops up in red here, because it's going to take into account your factor of safety. And if anything is red, that basically means you got a failure. So a very powerful tool, but at the same time, if you get into a lot of welds, a lot of complex welds, complex shapes, the weld calculator will give you a starting point, but you're still probably going to want to turn around and FEA it to verify that you have adequate welds. And another tool that's involved is the bead report. And we don't have any welds in here yet, but what the bead report will do is give you an Excel sheet of all the beads. It'll give you the volume of weld in there, it'll give you the length of the weld, and you can use this more on either the manufacturing end of things to get an idea of how long it's going to take to weld this machine up, or to estimate weld time. And you can also do it if you do need to cut some costs out of a machine and you do have it overly welded, where you can take some welds off and not compromise your design. That can help you determine too, you know, what kind of percentage time savings is if we would make, you know, say this is stitch weld, or cut this weld out, cut that weld out. So another very powerful tool. Just keep in mind you're exporting, you can't export that Excel sheet, and once you export it, it's disconnected from the model. So if you change any of the models, you'll have to go in and run a new bead report. And one other point to note is when you do hit that bead report, you can include all the sub-assemblies as well that comes into this. So if you have sub-weldments that come into this, you can have those added to the same Excel sheet. So for a given finished weldment, you can have the entire weldment, and all its subcomponents added into this one bead report sheet. And then to do that, you simply have to check this box, which by default I believe it is unchecked, at least in the 2020 version. So now we're going to go into the processes, and up here there's 3 processes. First of all, there's preparations, which allows you to, say for instance we wanted to grind some of this edge off so we can get a good penetrating fillet weld. Well, you can do that preparation here and grind that at this level. It does not affect the piece parts. It's simply something that is done to this level. Essentially it's doing a chamfer command to it. And once you go into that, it'll activate some of these tools here, which act just like your normal piece part designing tools. Then there's the welds, which obviously is where we do all the welding. And then there is machining. And the machining is typically seen as the post process. Once things are welded, say you want to machine 2 faces perfectly square, or to grind or machine a face to take out any warping that may have happened from the welding process. So that's the typical usage of these. Back on the preparations, we also use that. We don't use the preparations too much within our company because we build all the piece parts as needed the next level up. So if something needs a chamfer on it to weld at the next level, we'll put that chamfer on the piece part. But the other place that you can use preparations, and is where we use it, is if we want to do a plug weld or a spot weld, and I'll show you how to do that a little bit later.